Okay, if you don't know what's going on here or where these cells and that came from, go back and watch my previous video and you'll see what's happening here, where we got these Samsung 18650s from. So they're a 2P5S battery, 20 volts, 4 amp hours, and they are indeed Samsung cells. I've already done an amp hour test on them and they exceed the 4 amp hours, and that was only a drawdown to 3 volts per cell of 15 volts to the pack. Samsung say you can draw these cells down to 2.5 volts, but I stopped at 3. So from our 4.2 volts fully charged, I actually only took these up to 4.15, but we'll say from 4.2 volts down to 3 volts per cell, we did indeed get our 4 amp hours with some left over. You can see I've already stripped 3 packs of the BMS, and it's a little bit tricky with this, but what I do is I just put a screwdriver here and lever the BMS board up as much as I can get it, and then I get in here with a big pair of cutters, because I don't have any small ones, up, and I simply cut it like that, each tab, pull them out, fold it down the side of the battery, so when I do the next one we don't get an arc out. Now you're probably going to get some sparks and shit going on here, but if you're quick enough you won't do any damage to the batteries, and of course the BMS boards we don't want. And then this one here, do like so and so, and then we cut that one properly. And also you're going to have to peel off your heat sensor. It is going to rip the plastic off the batteries because they've glued it down pretty good in there. In this case it didn't, made a liar out of me. We were lucky with that one, didn't have a lot of glue on it. But these other ones, when I went to pull it off, it was well glued and pulled some of the plastic off the batteries. Big deal, not going to see it, it's not going to hurt them. Then we just fold our board open like that, give it a stretch, cut again. Now probably asking yourself, why don't I just desolder them? Well, you can have a go, but when I cut this off I'll show you something. And definitely not the best snips in the world. Okay, so hoping you're still in shot there. You can see here that we're soldered along the top of the board. If we turn it over we can see that we've also got bulk solder on the bottom of the board as well, which is underneath the pack. You could just heat each solder joint up and lever it up a bit if you want. I just found it quicker and easier to cut them like I did, and then we just fold that down the side of the casing like this, each tab, and this comes in handy when we're hooking our parallel banks up, and also when we're hooking our BMS up, because I'll grab this multimeter here, that is each pair of our cells. So this one here is obviously positive, maybe. There. So that to the first one on the opposite side is one cell pair, and then so on and so on. Clip fell off. That's the next cell pair, and like I said, so on and so on with each tab. This makes it very simple in our build to parallel two banks together, and also when it comes time to hook our BMS up, we have all our tabs exposed that we need to do so. The next thing we're going to do is go through, and I'm going to grab the grinder and I'm going to cut this knob off and all these little knobby things here, just to give us a smooth surface. So I'll go ahead and do it on all these packs, and we'll come back and have a look how it's going to go together. So this is for a 36 volt 8 amp hour battery pack, and when you're dealing with something as simple as this, it's quite an easy build. So not only have we got good cells in those cheap battery packs, we've got a very good building platform to make our pack for our 36 volt e-bike. Okay, like I said, I'll go through and get rid of all these little knobs and shit that are sticking up, and then we'll come back and have a look how we're going from there. Okay, so our little packs are all cleaned up. That one there keeps stabbing me. It's already put one hole in my finger. All cleaned up, ground off all the knobs. It's nice and smooth now, so they're ready to go. Just got myself a little bit of plexiglass. Just cut a bit of 5mm, and that's what we're going to use to sit our batteries on. Don't have to, but I thought why not, it'll make it nice and strong. And they're just going to sit like that there. And we've got our boogie gun here, we're just going to boogie him down. Good old roof and gutter silicon, clear. So that's the plan with that. We can start by just running a small bead up each leg. Hope I'm keeping you in shot here. It's a bit hard to watch and all this, but just sit that on there so it's nice and level, like so. Come back and trim the excess off a bit later on if we want. If we sit that cell there, we can see we get a bit on the bottom corner here as well, just so bonds our two batteries together a bit better. Probably not necessary, but we're doing it anyway. And we'll just slide that one in there like so. Keeping it nice and level on our bit of plexiglass. Nothing like working with silicon. Same applies here. Don't need too much. Just to hold the cells together. That went well. Like so. And same again with this one. Put down the bottom corner there. So nice and level. And that there, the size of my hand, is a nice compact battery pack, so we can either tape that up or heat shrink it, which I'm going to do. We're going to use my newfound poor man's heat shrink. Nothing like recycling, that you'll have to see in the next video, but for now we're going to let that silicon dry, and then we'll come back and we're going to hook up all our parallel and series connections. Now once this is dry, I'll fold all those tabs back up once I've trimmed off the excess silicone. I don't go and wipe it off now because I don't want to wipe it all over our steel, which we're going to be soldering in this case. You could use your zinc stripping and spot weld all your connections. In my case, I'm going to be using just 6mm 50 amp cable, copper wire, and that's all that's going to be required from here. With this pack, we're not going to be drawing anywhere near 50 amps. We've got a 250 watt motor at 36 volts. Haven't got the calculator, but it's probably going to be about 30 amps max draw. Well, not even that, 6 amps. Anyway, that's where we're at the moment, and that's a nice neat battery pack. It's got all our external connections we need for our parallel, series and BMS connections, and very nice. This is actually foam rubber on the plastic casings on the side here. So all in all, for our 36 volt e-bike, 8 amp hours. The cost so far is just our 4 battery packs at $30 each, which is 120 bucks. And like I said, these are Samsung cells, which I have load tested. They exceed the 4 amp hour capacity stated on the box. So all we've got to do now is wait for the boogie to dry, and then we'll come back and start doing all our wiring. Okay, so our silicone is it's not quite fully dry, or set should I say, but dry enough for us to continue on now. So we've got our pack. You want to take a bit of time and get a pair of pliers and flatten these out nicely. I'm not going to bother. And like I said, each parallel connection and series connection is going to be made using this 6mm square wire. This is good for 50 amps, and our parallel connections are only just over an inch long each, just enough to go from there to there, there to there, there to there, yada yada. And our series connection is actually going to go through this hole we've been left with, and then come up onto the negative of one battery and the positive of the other. So not much more to it than that. So like I said, our 6mm wire is good for 50 amps. We've got a 250 watt motor, 36 volts. These will be about 41 volts fully charged. So 41 volts to 250 watts, we're going to get a maximum of about 9 amps. So our 50 amp wire is more than capable of dealing with that, and the resistance across our longest piece of wire is going to be that small. Very little power will be dissipated by this wire, so quite fine to use. In fact, this is probably capable of carrying as much current as the 0.15 by 8mm zinc stripping we normally use to put our batteries together. But all our cells have already had the zinc stripping spot welded to them. I can see that by this little hole in the foam here that they are spot welded on, not soldered, so all good. So the next thing we have to do is determine negative and positive, and if you put all your cells so they're all facing the same way, the best way to do that is the little dicky thing we've cut off here to make our hole drawers smooth. Make sure they're all at the same end. So those two there forward or back, and those two there at back. This keeps your cells all in the same sequence. You'll see I already have a plus sign there, which means this one here must be minus. So we get our multimeter, and we simply make sure 20.4 volts without the negative sign, so this one here should be the same, 19. So this cell here has actually been charged. That's the one I first tested. The other three yet haven't been charged. Now I don't have a 36 volt battery charger as of yet. That's coming for good old Ebike. I do have a 0 to 31 volt power supply at 5 amps, so I can, even once we've wired all this up, I can still charge each bank individually or each bank pair, because we're only after 21 volts. We're not going to go any higher than that, and that'll allow our cells to last a little longer, not charging them up to the full 4.2 volts per cell, so we'll be staying around 4.1 volts per cell. So I'll go ahead now and I'm going to tin all our little parallel connectors and our series connector, tin all our bits that are sticking out here, our terminals, and solder it all up, and then we'll come back and have a look. Okay, so when I'm putting my wires on my little terminals, I like to take a screwdriver and push down on the wire, and it flattens it out a bit and gets it the same width as the terminals, and you get a really good joint. So I'll just get this one hot. And then we just put our screwdriver here and push down on the wire. Soldering iron off. Wait for it to cool. And you can see we get a really nice join there. I think you can see. So that's how we solder on, well, that's how I solder on the wires in this case. Also makes it pretty easy. So just thought I'd show you that. This one here you could do with a little more solder, and then we can just push that down there like so, push it with the screwdriver, hold it till it sets, and we've got a good joint. So we've got, might be hard to see black with black, but we've got one side of our series connections done, or our parallel connections should I say. So we'll go ahead and do this side and put our series connector in and come back and see how the finished product looks. Okay, so our all our parallel connections are done, and our series connection, which travels through the hole in there between the batteries there, is done. So we should have, these haven't been charged yet, only one's been charged, but we should have somewhere close to 40 volts across our positive and negative of our completed cell. Lead come out the multimeter, 39.4. So we're all good. Now, because all of our connections, our parallel and series connections are all exposed, it becomes very easy to hook up our BMS. So normally the BMS will have a one black wire, a negative, that will get soldered on there, and then the next wire will be number 1, the one after number 2, so on and so on, right up to your 10 cells. So your black wire starts there, and then 1 will go there from your BMS, number 2 here, number 3 there, 4, 5, 6, 7, 8, 9, 10. Actually, we've got to skip that one because that's our series connected one. They're both the same terminals in reality. So yeah, the N1's number 10. So that all works out. And the U-Butte light bulb above my head just blew out. That's why it might have got a bit dark. Nonetheless, I think you can still see. Yes, we're fine. So basically we've got to put our BMS on next, and that's our battery pack. So it's come up nice and neat. Of course we will wrap it when we're finished, and you'll get to see my newfound free heat shrink wrap, and strong as. Nothing like recycling. Alright, so now we've got to wait for our BMS, which is a week and a half away. So I'll post this video up just so you can see how simple it is to build this cell. So once again, that is 36 volts, 8 amp hours. They are Samsung cells, and they did test slightly above their rated capacity of 4 amp hours each battery. Well, I checked one, so I'm assuming the other three are going to be the same. Pretty safe bet. Yes, they're all Samsung cells, so good cheap source, and also the carriers that are inside those batteries make it very easy to make a e-bike battery. Right, thanks for watching. We'll be back when the BMS turns up. We'll solder that along, we'll go through it. They're really quite simple once you've done one or two of them. No problem at all. Oh, just while we're at it, in my last video with these U-Butte El Cheapo 4000 milliamp hour eBay specials, I did say that I only got 1 amp hour out of this 12 volt setup, and that means they only gave us an amp hour per battery. In actual fact, each battery is only half an amp hour, because we have 2 in parallel and 4 in series to get our 12 volt battery. So a claimed 4 amp hours, in reality only half an amp hour. If you see these batteries on eBay, avoid them like the plague. They are garbage. Alright, thanks for watching guys, have a good night, and we'll see you when our BMS turns up, and we'll wire it on, get it all wrapped, put my heat shrink on there. Beautiful heat shrink, this stuff, you wait till you see it. It'll cost you nothing in reality, and it is a lot stronger than the heat shrink you have to buy for these batteries, and it is your claim to fame of recycling. Cheers guys.